Hello everyone, this is Chandra Shekhar welcoming you all to the one and only the Daily Dose series for civil and mechanical engineers. The main objective of this series is to bring the most important either a concept or a question for the student's benefit. And in today's session, I have selected one question for you and the subject is fluid mechanics and the topic will be compound pipe. The question you are already familiar with, but we will try to solve this question with a unique and the most efficient approach. So that will help you to improve your understanding of the concept basics of compound pipe, that is series or parallel combination. So because there is a question on the screen, so I will be showing you the question on the screen. So I want you guys to solve it on your own parallelly so that you can be able to judge whether your solution is correct or not, or how is your approach. Is it the same approach or your approach is different from mine? So this is my quick introduction for those who are meeting me for the very first time. Let us start with the question. So the question says, it is a common data question. You guys must have already familiar with a pipeline having the diameter 0.3 meter and the length 3 kilometer carries water from point P to point R. Figure is also given. I will show you the figure. This is the figure given. The pipe is between P to R. It is carrying water. The fluid is water and the piezometric heads at point P and point R are to be maintained at 100 meter and 80 meter respectively. The piezometric head at P is 100 meter and the piezometric head at R is 80 meter. All right. To increase the discharge, another pipe is attached in parallel to the existing pipe between Q to R. So as you all must be knowing that whenever we want to increase the discharge in a pipe, what we are supposed to do is we attach another pipe in parallel to it, because when we attach the parallel pipe, the loss remains constant but the discharge get increased, and that is how we have attached the parallel pipe to increase the discharge. Now the length of the additional pipe between Q and R is also 2 kilometer. It means the original pipe between Q to R is also 2 kilometer and the additional pipe is also having the same length, 2 kilometer. Now assume the friction factor, Darcy's friction factor 0.04 for all the pipes and ignore the minor losses. Now the question starts, because we know that the additional pipe will definitely increase the discharge in the pipe. So the question says, what will be the percentage increase in the discharge with the additional pipe? And the additional pipe is having the same diameter as that of original pipe, that is 0.3 meter. Have you understood the question? First of all, you need to understand that whenever we attach a parallel pipe anywhere in the main pipe between P to R anywhere, if we attach another pipe in parallel, then definitely the discharge will get increased. So the question says, what will be the percentage increase in discharge? Options are there on the screen. Please try to solve this one. Or those who are not knowing how to solve, please do solve it with me. So do you agree if we apply the energy equation between P and R? If we write energy equation between P to R. Why? Because piezometric head at P is known, piezometric head at R is known. So we can say the total head at P is equal to total head at R plus the loss between P to R, isn't it? And according to continuity equation, the velocity at P must be equal to velocity at R because the area is same. So we can say this will become the piezometric head, velocity get cancel out. Then the piezometric head at P is 100 is equal to piezometric head at R is 80 plus the loss between P to R. So from here we can say the loss between P to R will remain constant. That is, even if we attach a parallel pipe, the loss between P to R will remain same. So let me assume the discharge Q as without additional pipe. Without additional pipe discharge is Q and Q dash is the new discharge with additional pipe. The discharge without additional pipe is Q and discharge with additional pipe is Q dash. So what we need to do here is Q dash is more than, we know Q dash is greater than Q because of the additional pipe. So Q dash minus Q upon Q into 100 is the objective, or we can say Q dash by Q minus 1 into 100 will give you the answer for discharge, increase in discharge in the additional pipe. All right. So if we talk about first and second case, so we can say loss between P to R in first case will be equal to the loss in P to R in second case. There is no change in the loss because the points remain same and energy is the point function. The loss will remain constant between P to R. That will be 20 meter. 80, 100 minus 80. That will be 20 meter. So if we see whatever is the discharge Q dash will be equally distributed in both the pipes, Q dash by 2 and Q dash by 2. Why? Because the loss between Q and R, as the loss between Q and R is either written as HL1 is equal to HL2 because of the parallel combination. The loss will remain constant and the diameter D1 is equal to D2, as the D1 is equal to D2 and L1 is equal to L2 and F1 is equal to F2. So from here we can say Q1 is equal to Q2. That will be equally distributed. That is equal to Q by 2, Q dash by 2 each. The discharge will be same. All right. So we can write F. The length between P to R is 3 kilometer. Let me use 3 kilometer only. Then Q square upon 12.1 D to the power 5 is equal to, how to write loss between P to R in second case? We will write loss between P to Q and loss between Q to R separately. So we can say F, the length between P to Q and the discharge in P to Q is Q dash upon 12.1, diameter is D to the power 5 plus F, the length between Q to R into Q dash by 2 square upon 12.1 D to the power 5. Diameter of each and every pipe will be same. I hope this is clear. Now, if we further simplify it, denominator get cancelled out. F is same for all the pipes. Then it will be 3 into Q square is equal to, what is the length from P to Q? 1 kilometer into Q dash square plus the length between Q to R is 2 kilometer into Q dash by 2 square. This will be the expression, or we can further simplify 3Q square is equal to, this will become Q dash by 2. So Q dash square into 1 plus 1 by 2, 3 by 2, that is 3 by 2 Q dash square. 3 and 3 getting cancelled out. So what is Q dash by Q? What is the value of Q dash by Q? So Q dash by 2, or we can say Q square is equal to Q dash square by 2. So we can say Q dash by Q is equal to root 2. Isn't it? That is 1.414. And what is Q dash by Q minus 1? That is equal to 0.414 into 100 will be around 41.4%. That will be the answer for the first part. 41.4% will be the answer. 41% is the correct answer. Now there is one more part for the same question. Let us talk about the next part. Now if there is no restriction on the diameter of the additional pipe, the diameter D2 can increase up to any limit. What would be the maximum increase in discharge theoretically possible from this arrangement? All right. So now, do you agree if diameter D2 increases? Do you agree if the diameter D2, this is D2. If diameter D2 increases, it means the flow area increases. So Q dash increases further. The discharge will increase further. Q dash will increase further. And if Q dash increases further, do you agree the loss between P to Q will increase? The loss between P to Q will increase because the discharge is Q dash. Nothing else is changing between P to Q. It is only the discharge which is changing between P and Q. So the loss between P and Q will increase, and the loss between Q to R will decrease. Isn't it? Why? Because the total loss between P and R is constant, that is 20 meter. So if there is an increase in loss in P to Q, there will be decrease in loss from Q to R. So for diameter D2 becomes infinite, what we can say, Q dash becomes maximum. And if Q dash becomes maximum, then for diameter D2 infinite, HL2 will be 0. HL2 will be equal to 0. That is equal to HL1. That is equal to HLQ to R. The loss between Q to R will become 0. So the loss is only between P to Q. So if we apply the energy conservation equation, the loss between P to R in first case is equal to loss between P to Q plus the loss between Q to R in case of second case with the additional pipes, and this will become 0. This becomes 0 when diameter D2 becomes infinite. And if this becomes 0, so we can write F, then the length between P to R, discharge earlier was Q square upon 12.1 D to the power 5 is equal to F, the length between P to Q into Q dash maximum square upon the diameter remains same D to the power 5. If you simplify this, this gets cancel out. Friction factor is same. Then we can write what is the length between P to R, 3 km, then Q square is equal to P to Q is 1 km, then Q dash maximum square. What is Q dash by Q? Q dash maximum by Q. Isn't it root 3? Isn't it root 3? Root 3 means 1.732. So if we want to find out Q dash by Q minus 1, that is 0.732, or we can say 73.2% will be the maximum increase in discharge theoretically possible from this arrangement. So the answer to the question will be option C. I hope this is clear and you guys have enjoyed it. For many such sessions, please do subscribe our BYJU'S YouTube channel. Stay in touch, keep healthy, keep preparing with your full dedication and hard work. Thank you guys. Thank you very much.